Hello, good evening. Hello. Good evening.
Hello, good evening.
You are hearing me? Voice not good?
It's okay, doctor. Your voice is clear.
Yeah, it's okay. Hello.
Hello, doctor.
Welcome back.
Hello, sir.
Last session we stopped at Brighton cycle example, correct?
Yes.
Yes.
Okay, we'll start today by the next slide for the exam, for the question for Brighton cycle. Start by some theoretical questions. Which is false statement about multi-stage compression?
Where is the question?
Presentation. The presentation you cannot view.
Your answer?
Sir, could you please share this one?
Not sure.
Presentation is not shared.
Sorry.
Thank you.
Yes, start sharing now.
Yes.
A.
A. All agree?
B, I think efficiency will be higher in multi-stage compression.
Yes, the
False.
statement
False
about
statement.
stage is volumetric efficiency is high. In multi-stage compressor, isothermal compression is achieved by
Employing intercoolers.
employing intercoolers. All agree?
Yes.
Multi-stage compressor, isothermal compression is achieved by running compressor at very slow speed.
Is it? Huh?
Okay, why we use multi-stage compressor? You remember at the end of the session when I describe Brighton cycle, I tell you the constant pressure. It is close together from the left side and going to be far from the right side, correct? Remember? I think you don't remember. You remember?
What is that?
This compression and this expansion by turbine. This constant pressure with this constant pressure. But in the left side, when going in the left side for TS diagram, we will see this line is close together, and when going right, we will see this line is far together.
Yes.
Remember this or no?
Yes.
Yeah.
Yes, sir.
According to that, this is the reason for to use it multi-stage compression. To don't go up direct. We use multi-stage to decrease the compression of compressor used. So instead of going direct from this line to this line, no, I divide it like this. I go here and go to cooling, and then going again to compress, then cooling, then compress, then cooling, then compress, up to reach to the final stage of the pressure required. So instead of going direct from this point to this point, it's better to make it like stages like this. The total amount of the work consumed for the multi-stage compression is less than from the compressor direct from 1 to 2 by one stage. See with me this diagram in details here. If you're going direct from B1 to B2, this final stage, this first stage or initial stage, this first stage, this last stage. If you're going direct like this, it takes more power. But if you're going to divide this one in stages, you'll see at the end the total power consumed is less. So if you're going to the first stage and going to intercooler, then second stage to going to intercooler, and then going to third stage, you will see the total amount of the compression here is less than the total if you're going by one stage. It's clear? So you're going to make work safe. Clear this one?
Yes, sir.
Same here to present how many work saved here.
But sir, in question, you mentioned that the second number question.
What's the problem for second question?
Yeah, in that multi-stage compressor is used for yes, running at slow speed. Or
Yeah. This is for isothermal compression. Actually, what we will do in practice, not this, because actually in practice we can't do move in or running in low speed. But theoretically, yes, this is the way. But actually, in practice, we can't do that. We make another things. We will see one question related for that.
okay. So answer is that slow running is the answer,
Yes,
right?
yes. Adiabatic compression is one.
No heat leaves or enters the compressor. Bravo B.
All agree? All agree for that? Hello, engineer. All agree?
Yes.
Capacity of a compressor is 5 meter cube per minute. Refer to
Three area.
free area. Yes. Overall, isothermal efficiency of compressor is defined as the ratio of
Delta.
Let's see.
A.
C.
C power to drive. No, I don't think so. Isothermal efficiency is isothermal horsepower to brake horsepower. Okay?
Okay.
Most efficient method for compressing air is to compress it
Isothermally.
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 Correct. Here you can check with me. If you press isothermally, this is the minimum work consumed for this one, which is PV equal constant. It means at index number equal to 1. I think we have one question before we solved it. N equal to 1, this to obtain minimum work consumed. Okay, so PV equal constant. PV to power gamma, which is adiabatic process, this is the maximum we can obtain, maximum, not minimum. PV to power n, which is polytropic, this is in between. Okay.
So means when expansion, then we'll get the maximum work in PV raised to gamma is adiabatic.
Adiabatic is maximum work.
And we will get minimum work in the isothermal.
At gamma or n equal 1. PV to equal constant isothermal process. This is minimum work.
Okay.
Maximum work is done in compressing air when the compression is
Isothermal. A.
isothermal. All agree? All agree?
No.
Yes.
Read again question and give me answer.
No. Minimum work is done.
Adiabatic. B.
This is a poly. Adiabatic.
Adiabatic. All agree? All
Yes.
agree?
Yes.
Yes, correct. Not
No.
isothermal. Please read carefully, okay? This one is isothermal efficiency of compressor. Present here different for ideal process and theoretical or isentropic process or ideal one. This one is theoretical one or isentropic one. If you're going to isentropic, it means the S equal to constant, this isentropic process. So we're going straight like this. And for sure, this, if we talk about for compressor, the isentropic is less than the actual. If we talk for turbine, the for turbine, the isentropic is more than the actual, correct? And depend on the function, because for compressor, we need to consume work. So if in ideal case, this less. For turbine, we need to obtain work. So for ideal, is more, correct?
Yes.
For example, for turbine, it's going to be like this. Isentropic going straight, and other one is going like this. So we'll found isentropic is higher. Clear?
Yeah.
3 to 4, for example. Okay, by the way, the equation is the same. Isentropic efficiency for isothermal efficiency is equal to isentropic work divided by actual work. Isentropic divided by Y actual. Okay? The pressure and temperature condition of air at the section of compressor are
E. E for England.
which one?
E.
Yes, E.
Okay. Pressure is slightly less than atmospheric and temperature slightly more than atmospheric. Correct. Isothermal compression efficiency can be attained by running the compressor
At very slow speed.
at very slow speed. Compressor capacity will, with decrease in section temperature, what happened?
Increases.
Increase. A.
Increases.
Increases. Isothermal compression efficiency, even when running at high speed, can be approached by using
Yeah, A and B.
C. C.
C. A and B.
excellent. Compression efficiency is compared against
B.
Isothermal.
B.
isothermal compression. Airplane employee following type of compressor.
Axial flow.
Radial flow.
Axial flow.
Finish?
None of them.
Actually, axial flow. Intercooling in compressor.
Results in saving of power in
Sir, B.
compressed
B results in saving of power.
Saving power.
Yes, sir.
Sure.
Yes, sir.
Intercooling. The reason for intercooler is result in saving of power in compressor. This is easy and quick problem. Can you solve it, please?
P1 V1 by T1.
A.
A. All get the same answer.
Yeah. P so and this one is J so. Double it will be.
No, it's B.
3 meter cube. Just we'll use which one? What will be the
P1.
volume of air if its volume is blah blah in the first stage? So V1 over V2 equal T1 over T2. That's it.
Can you write the formula?
P1 V1 by T1, right?
Yes, I write the formula. Okay.
Yeah.
Yes. One. Alpha.
1.
Yes.
All agree? No one here? Only one? Yes, when equal n equal to 1. Same curve we presented before. Isothermal compression through most efficient.
B for Delhi.
Which one?
D.
Delta compressor has to run it.
Sir, D.
D.
Because if it runs at low speed,
Yeah,
it will not compress
running
enough.
at low speed because it's about for isothermal compression again. Yes. Ratio of indicated horsepower to brake horsepower.
Isothermal efficiency.
Which efficiency?
Mechanical efficiency.
Mechanical efficiency. not
Mechanical.
isothermal.
Yes, almost right. Yes, correct. Ratio of work done per cycle to the swept volume in case of compressor is used.
Compression ratio.
Index. Just guessing. E.
Final. mean
The
effective pressure.
mean effect.
Here, just brief for what is the swept volume, what is effective swept volume, what is total volume. Actually, this here represents for the total volume available. This is the total here, represent for the total volume available. This one is the swept volume for maximum volume for the cycle and the minimum volume for the cycle. This is swept volume. And actually, for the process itself, this is the effective swept volume. Swept effective swept volume. Volumetric efficiency. What is the volumetric efficiency? Effective swept volume by swept volume. That's it. This is volumetric efficiency. Effective swept volume to swept volume. And what is clearance ratio? Clearance ratio, it is clearance volume by swept volume. Clearance volume by swept volume. Cylinder clearance in a compressor should be
B.
B.
As small as possible.
As small as possible.
as small as possible. Great. Ratio of compression is this ratio of
Charlie?
spinal
A.
no B.
B.
So this is pressure to absolute intake pressure.
Okay.
Here also represent again here this volume of combustion chamber when the bottom reach to top dead center. And this is mentioned for swept volume. This is the area below.
Yeah.
Clearance volume is in actually reciprocating compressor is essential.
E. E for England.
Which one?
E.
E?
E.
Yeah, great, correct. This is not important. Which of the following plants is the smallest and lightest for generating a given amount of power?
Gas turbine plant. E.
Any other idea?
E gas turbine.
Yes,
E.
correct.
Solar.
No, gas turbine is still the smallest one. Simple turbojet engine is basically
Bravo.
Yes, B.
B, sir. B for Bombay gas turbine plant.
yes, gas
with a
turbine equipped
propulsion
with a propulsive nozzle and the fuel. This is what we will see next the slide here. Here is some types of the jet engine like turbojet, turbofan, ramjet, scramjet. Just we will describe a small brief for each one. First, I will describe jet engine design. Jet engine design is consists of normal engine, same like gas turbine, like compressor, combustion chamber, and turbine. But here in jet engine, just we add at the beginning diffuser before you going to the compressor, and at the end we put the nozzle before we face the just turbine direct to atmosphere. No, after turbine going to continue to expansion by nozzle. Okay, so the process is the same process for gas turbine, but just we extend the part of diffuser and the part of nozzle. So the process instead of start from 2 to 3 only, Now we start from 1, which is referred to the 1 to 2 is diffuser, isentropic compression in diffuser. And continues the same isentropic compression in compressor, 3 to 4 Q added in combustion chamber, constant. Then going to expansion, the same expansion up to 4, which is turbine, isentropic expansion. But here we continue expansion and we get it at 6 isentropic expansion in nozzle. Okay.
Yes, sir.
Here's some brief for each one. For ramjet, it has no moving parts. Its compression ratio depends upon forward speed. Has no static thrust. Guided missile. Space vehicle use this type of jet. Also here, I think uses this in high pressure in front of the engine. What else? Accelerated to supersonic. It's working in supersonic. Okay. Scramjet is subscribed from supersonic combustion ramjet. Okay, this supersonic combustion ramjet. So scramjet is working in higher speed more than ramjet. Ramjet, if it's working in a supersonic range, okay, but here this working in supersonic combustion, it means more than ramjet. For scramjet, almost in high in what hypersonic speed, not normal like supersonic. That's it only. No, it is hypersonic speed, and this hypersonic speed starting from almost 4-5 Mach number and going to up. Here, if we don't need to talk for this one, just designed by using hydrogen as a fuel and oxygen from atmospheric. Turboprop jet engines. This turboprop will join the shaft of compressor at the end by gearbox and propeller. Here, I think no mention. Just mention for consists of intake, compressor, combustor, turbine, propelling nozzle. That's it. Last one, turbo shaft. Turbo shaft here is variant of jet engine that has been optimized to produce shaft power to drive machinery instead of producing thrust. And this is the shape for this one here, like this. Normally we use this one for helicopter. Okay, some questions is related for this part. It's slightly, some of this question is difficult, but just be aware for the type of the question for this part, not more. For speed above 3,000 km/h, it is more advantage to use
ramjet engines B.
ramjet engine, correct. Excellent. This mentioned here for ramjet, it is within the range of 2 Mach number to 5 Mach number, and up to more than 5 Mach number, it will be scramjet. Okay. Ramjet engine. Any no idea?
No ideas.
No problem. For this question, no problem. Is not self-operating at 0 flight speed. Air breathing jet engine. The jet is formed by expanding
Plasma D.
E. Highly heated.
E, sorry.
highly heated atmospheric air. Correct. Aircraft propeller. No idea also?
All of the above?
Yes.
Guessing.
Maximum temperature in a gas turbine is what?
E. E for England.
700.
700, yes, correct. Work ratio of a gas turbine may be improved by
A and C.
A and C,
A.
increasing turbine work and decreasing compression work.
Eco.
E for elephant.
one more option.
Yeah, eco, sir. A and C.
Decrease the compression work and increase the turbine work. Work ratio of a gas turbine is ratio of
Sir, B. Sorry,
net
C.
work
Turbine and heat supplied.
work done by turbine and the heat supplied. Actually, mainly heat talk about for work ratio. So almost work ratio means almost all work. Net work output and work done by turbine. This is schematic for the reheating in gas turbine.
D.
This schematic mentioned for this compressor, this combustion chamber, this turbine. But the turbine, it is going to be stages. You remember steam power plant when I discussed steam power plant and reheat?
Yes, sir.
This is almost
Yes.
the same. We're going to the stages of turbine. The first turbine, the output of this one, going to reheat it again from the line coming from the combustion. So the temperature is increased again, and they're going to continue expansion by the second stage of the turbine. Okay.
Yes, sir.
So in this case, what is the benefits for that?
Delta, sir, both in increase of work ratio
Increase
and
of work ratio, because work ratio it is mainly direct for the net work to the turbine work. So increase work ratio. Only that or another thing?
I don't, not sure about decreasing of thermal efficiency.
Not sure. But
Yeah.
here it's sure. Increase of work ratio and the decrease of thermal efficiency. The thermal efficiency at all is decreased. Main purpose of the heating in gas turbine is be careful, please, because he mentioned main purpose.
Reduce.
C.
E increases speed, increase pressure ratio.
C. C.
No, actually the main purpose increase power output. Reheating in multi-stage expansion gas turbine.
Sir, reheating is what? Which was the process, sir? I forgot actually.
Reheat, it means we divide the turbine in stages, and after expansion for first stage of turbine, take this amount of the output and they make a reheat with the output of the combustion chamber to heat up the temperature and
E.
going to second stage for the turbine. So you obtain more
D.
work output from turbine because you increase the temperature again, correct?
So in the same turbine, it is going to the second stage with increased temperature.
Yes.
In the same turbine, not in the other turbine.
No, second stage of the turbine, not first stage. First is this
Mm.
stages of turbine. First stage, second stage, it's multi-stage.
Yeah, maximum work output, delta. It means
Delta. Yes. Compression ratio in a gas turbine is of the order
8 is to
12
1.
is 12, 8 is to 1.
8 is to
8
1.
to 1. 8 to 1. Gas turbine cycle with regenerator. Regenerator is slightly different for reheating. Regenerator, you take the exhaust for the last stage of turbine. Last stage of turbine, the output is exhaust, correct? Normally, this exhaust it is still in high temperature. So instead of lose this energy in nothing, no, take this one, this branch, and connect it to like heat exchanger again. Connected with the make heat exchange, heat transfer between this the exhaust and the output of compressor. The output of the compressor is air, correct? Still, the temperature of the air is low temperature, and going to in combustion chamber to mix with fuel to burn and obtain energy, correct?
Yes.
So before air going to the combustion chamber, just I going to heat exchange this line of the air with the exhaust of the turbine
Okay.
before I lose this exhaust. So what happened? I increase the temperature going to the combustion chamber. So you increase what? The efficiency total for the combustion chamber and
Yeah.
decrease what you
Heat
added.
input. Heat input.
Correct? Yes, you decrease Q added. If you decrease Q added, what happened?
Increase thermal efficiency.
Yes, there. Same like this. The output here is around 250 to 300. Just going back again here to mix or not mix, just heat exchange between this line for the exhaust and the line coming from the compressor to the combustion chamber. Clear?
Okay. Yes, sir.
The working fluid in air turbine is
B. No.
working fluid in air turbine is mention here air. So it
Air.
is one single phase. One single phase. Specific output per kilogram mass flow rate of a gas turbine having been fixed efficiencies with one turbine and fixed higher and lower temperature with increase in pressure ratio. Well, increase pressure ratio. Remember the curve.
First increase, reach maximum and decrease.
Yeah, going to increase, then maximum, then decrease. This curve you studied before, correct? Back to the slide for this session, this slide, and you found this curve. In jet engine, the compression ratio
A.
Variance and square root, not square root. Actually,
Okay, very
it's
just.
variance with the square of
Sorry.
the distance. In which case, the air to flow ratio is likely to be maximum.
2:.
No, it is maximum for
Four stove
gas
petrol
turbine.
in gas turbine.
Yeah. Yes.
Just this one here is the definition of air to flow ratio. And this is the air to flow ratio. It is the amount of air and the fuel to produce a chemical complete combustion. The air flow ratio in gas turbine is of the order
15:1. B.
actually
No.
answer what? B? No, actually it is
50.
E. This we discussed before for one question before. Compression
Yes.
ratio is simply ratio of the absolute. Hi, this just remember the two slides before and check this question.
To increase the efficiency.
To increase efficiency. B.
Reduce the exit temperature
Oh.
because we have more excess air. So this air is not burning and use it only to decrease the exit temperature. Effective power of gas turbine is increased by adding the following in compressor.
Ammonia and water vapors.
Ammonia and water vapor. Which is
Creep, sir.
important.
C. Creep.
Creep. C.
Creep, yes.
Stainless steel. High alloy steel. High steel. Delta. Oh.
Now,
E. Eco. High nickel alloy.
E.
Nickel.
yeah. High nickel alloy. Pick up the wrong statement. No idea? Difficult? Pulse jet requires no ambient air for propulsion. Fighter bomber use following type of engine.
Sir, turbojet.
Turbojet. Correct. This Otto diesel and dual cycle. Actually, the 4 or 3 cycles is almost the same. Okay, but what is the main difference between these? Is this already discussed? Gas turbine, which is reverse Brayton cycle. But this Otto for a spark ignition engine, diesel for compression ignition engine, and this is mixed between these two. Actually, almost all process for the compression process, and expansion process, and the Q rejected, almost all the same. The 3 is the same. What's the meaning of that? The compression is from 4 to 1 here from 5 to 1, here from 4 to 1, all the same. 4 to 1 is isentropic compression. All the same, isentropic compression. Also the 2 to 3, 3 to 4, 2 to 3, This isentropic expansion, isentropic expansion, the same name of the process. Q rejected, all it is happening at constant volume, 3 to 4, 3 to 4, 5 to 4, all the same. So what is different? The difference is the part of Q added. That's it. Q added for Otto, it is happen at constant volume. Q added for diesel, it happen at constant pressure. Q added for dual cycle, it is two parts. First, it's added by constant volume, then going to continue by constant pressure. Here for all?
Okay.
Okay. Some simple question for that. If I keep compression ratio is the same for all cycles. So the compression ratio is the same for all cycles. Which one have higher efficiency? If I put all the same compression ratio, or as a higher efficiency is Otto cycle, then dual, then diesel. Dual is almost for all in the middle.
Auto is maximum, huh?
At the same Q added, if we fix the amount of Q added for all, which one higher efficiency? Which one higher efficiency?
Diesel maximum.
Otto again is the maximum efficiency if the Q added the same. If you fix the Q added for all, so efficiency for Otto is higher. If the same temperature maximum, all reach to the maximum temperature and all the same, which one is higher efficiency? Here in this case, we will found diesel is higher efficiency and lower efficiency is Otto. Last thing, if we fix all and we constant all at same maximum pressure, so efficiency what? Efficiency also for diesel is higher than dual, is higher than Otto. So if all cycle at the same B maximum or T maximum, so diesel is the top. If the same Q added or compression ratio, Otto is the top. What is compression ratio here? For the same compression ratio, what's compression ratio? This is V here maximum divided by V initial, V4 over V1. That's it. This is the same part here. Okay. Going to another slide. Sharing start.
Yes.
Sharing start.
Yeah. Yes.
Okay. Here's a part for HVAC. Reverse cycle. Actually, for the ideal thing, we study first reverse cycle, same like Carnot cycle, but this in a reversed way. For example, this low temperature media, this high temperature media, the flow is going from the low temperature media to the high temperature media, but in this case, we need extra power to make this process, okay? Here, instead of efficiency, we use another thing. It's called COP. What is COP? Coefficient of performance. Coefficient of performance. And in this case, the important thing for me is this one, which is mentioned to COP, this beta, this name. But we have another name, COP. This is a famous one. COP for refrigerant, refer to refrigerant. COP of refrigerant, C, it means Carnot. It means or cycle, refrigerant cycle. But what I need here is reversed Brighton, reversed Carnot cycle. It means the ideal one, the maximum you can obtain. The maximum you can obtain. If you remember Carnot, the minus it is up, and the denominator it is only have TH, which is referred to hot. But here TL is above, and the difference is below. TH minus TL. TH minus TL. So COP for refrigeration cycle, it is equal to the low temperature divided by the difference between high and low. Okay? The same heat pump, same equivalent also, but instead of TL, we put TH. That's it. Very important one. The basic refrigeration cycle. It consists for what? It consists of 4 elements, and this 4 elements very important. What is this 4 element? This one compressor, then going to condenser, then expansion valve, then evaporator. Again, compressor, condenser, expansion valve, and evaporator. Here it's presented by TS diagram, but I'd like to present by BH diagram. I'd like and the preferred BH diagram. Sorry. For air refrigeration cycle. BH diagram, we will find something like this. This media, this cycle is working between 2 pressure level, high pressure level, low pressure level. Again, high pressure level, low pressure level. If we check this something like this, low pressure level, high pressure level. Which one is in the part of low pressure level? We will find the low pressure level in the part of evaporator. It's coming from after expansion and going to compressor. But after compressor, we will find this the part of high pressure range. So this is the condenser pressure. This is the evaporator pressure. The process as it is, one is going to compressor and out at 2. So one is here is at least totally superheated, Why? Because it's going to compressor. Compressor is totally different for pumps. Pump is need totally water, but compressor is need totally air. So this is the point 1. Number 2 is constant constant entropy, as you see here, constant entropy. But in BH diagram, the constant entropy like this. So this 2. After 2, this constant is okay. Let's equal constant. Isentropic process. From 2 to 3, this is due to condenser, due to passing through condenser. And for this one, from 2 to 3 is constant pressure passing through condenser. From 3 to 4 is going in expansion valve. So in expansion valve, we have one Important thing. What is this? Enthalpy equal constant. Enthalpy equal constant, or delta H equal constant. Change of enthalpy is equal constant. So the enthalpy is equal to constant, and going direct like this. Enthalpy constant. So what else? COB. COB in actual equation. Actual equation. COB is what? COB is output by input. The same concept of efficiency. Output by input. If we check together, output, we found output is the coolant fluid you needed, and the input is work compressor. So the COB for any refrigeration cycle can be used the simple equation for QL by work compressor. Okay, how to calculate QL? Same like the previous study. Difference between two enthalpies before and after. That's it. H1 minus H3. 1 and 3, but it is not 3. This 4 evaporator in 4. This is the part of coolant load. It's not 3, it's 4. So if you check here, you will find the 3 and the 4 on the same line. 3 and 4 in the same line. So as an equation, we can mention by 4, but we mention here in 3 because 3 is the same 4. If you get 3, you can get 4. Okay. For the equation, put 3 because 3 is easy to get it from the chart direct. 4 should be make the line perpendicular like this to get the H4. Okay, but in exam have to insult this before and after you can get what you need. Work compressor, it's happen between 1 and 2, so it is H2 minus H1. Any question for refrigeration cycle? It's coming a lot in the exam, this one. Hello?
Yes, sir.
Just I check network with you.
Can you, hello, doctor? Can you repeat again, Ma?
Okay, which one?
Regarding the
COB
COP.
or cycle? This one or beach diagram
Regarding
for all? Which one?
regarding coefficient of performance.
All?
No.
Coefficient of
Coefficient of
performance
performance.
is equal to coolant fluid divided by work compressor. And as the previous, same like previous, we will agree together any equipment installed for this equipment, it is difference between before and after. That's it. What is the energy after? What is the energy before? And going to be changed, make a change between these two, and we get the result for the equipment. Okay. So for coolant fluid, this coolant fluid is related for evaporator part. So it is H1 minus H3. H1 minus, H1 minus H4. H1 minus H4. This is before and after here. Before, this is before and after. Work compressor, it is between 1 and 2. So H1, H2 minus H1. H2 minus H1.
So
What else?
condenser is not coming in picture in COP.
No, not including. Any more question? Okay.
And in the temperature, what is the COP like T temperature term?
Which temperature?
Like earlier we read na the temperature TL upon TH minus TL.
TL.
That is COP.
TL. COP for the other one is ideal one.
Ideal.
Same like steam power plant and Carnot cycle. I tell you, Carnot cycle or same like the previous Carnot cycle or refrigeration cycle, it is ideal. This is the maximum efficiency you can obtain.
Okay. So this one is the actual, this refrigeration cycle.
Which actual?
This one, this refrigeration cycle is not the ideal one.
No, this is not ideal. This is actual one. For actual, we use energy as it is enthalpy.
Okay.
For theoretical, we use temperature. We can change or describe the heat or work by temperature.
Okay, sir.
This one type related for absorption system, absorption refrigeration, but we don't go in detail for this one. Just I give you the shape for this one to be aware. We have another type, it is absorption system, but we don't go in detail for this one. The question related for this part, we will see in the question here. Other type of the air standard for the refrigeration cycle is have a name for air standard refrigeration cycle. Air standard refrigeration cycle or reversed Brighton cycle. Brighton cycle for gas turbine. This reversed Brighton cycle. So the previous one, media is refrigerant, same like Furion, like 410, like 314, like Furion 22, and so on. Okay, but here the media is what? Air, because this air standard cycle. So this air standard cycle. The area here is air standard refrigeration cycle. What's component? Same like almost as the previous one. Compressor here. This one is like condenser. This like evaporator. This expander. This what? This expander. Okay. For this one, we can represent it in TS diagram. As you see here, from 1 to 2, this isentropic compression. From 2 to 3, this Q added. From 3 to 4, this is a process for expander, isentropic expansion. Then from 4 to 1, which is referred to the evaporating point. Actually, the application for this cycle, one of the famous application for the air standard refrigeration cycle, airplane. For airplane, how can the not refrigeration, but maybe the thing like a Hvac or something like this, how it works? Actually, we bring air from atmosphere because this one have a low temperature, so it's better to use a direct refrigeration, something like this, and to continue. Excuse me, what you see? What you said, please? Okay. So for application, one of the famous applications is airplane, and in this case, we will found this cycle is open cycle. Open cycle, it means the force element here will be cancelled, no force element. Okay, but in this case, the air going from outside, from atmosphere direct to the compressor, then compressed up to number 2, then here for H rejected, then going to 4 for expander. That's it. Okay.
Okay.
The process is almost the same. One to two for compressor. This also isentropic. 2 to 3. This constant pressure. Constant pressure. Same like here. Constant pressure. 3 to 4 is isentropic also. In this case, the coefficient of performance is equal to QL divided by work net, not work of compressor only. Why? Because here the compressor is part of this compressor is derived by expander. Because this expander, so we can obtain a small work from this one can be derived a part of compressor. So we use a little work here. Understand me?
Yeah.
This is the reason to write here work net. Okay. Also here we can use the same equation applicable for Brayton cycle, which is B T over T equal B over B to power gamma minus 1 over gamma and so on, because this cycle is what? Air. Okay. Okay. Just take relax, breathing. We're going to use psychometric chart. Just 1 minute, I drink water. Psychometric chart. I will present with you here one simple psychometric chart, and also I will tell you another one. But here, this one simple, they're going to the hard one. Okay. First, for this one, we will see some lines because questions coming asking for the lines, vertical, horizontal, and something like this. We will found here this line, this axis for dry bulb temperature, and temperature decrease when you're going left, temperature decrease. Vertical line, this represent to dry bulb temperature. Any question, ask me please. Vertical line, this represent to dry bulb temperature. Horizontal line, this represent to humidity ratio. Humidity ratio, okay, for the horizontal line. Curved line, this represent to humidity, relative humidity. Relative humidity. This what? Curved line. Last line here for the curved one, this represents for 100% relative humidity. 100% relative humidity. Up to this level, okay? Okay, I continue. For inclined line, we have two things. In this chart represent one, and after that I will show with you another one to show the another line incline. But first I will present here the first line, inclined line. Why? Because these two variable or two parameters, the inclined lines is almost typical. Not identical, but typical, just slightly shift. So if you found only one inclined line same like this chart, normally this line represent two enthalpy. Represent what? Enthalpy, same like this. One asked me, I need to check if this enthalpy or not. Maybe this represents to another inclined line. No, I can check quickly. To check, just check the value for the line with what? Check here with intersection with relative humidity 100%. This 100% relative humidity. And at this point, the intersection going down. Check the temperature for dry bulb. If the temperature here of the dry bulb is the same value for the inclined line, so this represents another thing, not enthalpy. But it is, if it is different like this 40, and here is almost 6 or 6 point something for temperature, so it's totally different. So this one represents enthalpy. Clear? So what is the other inclined line? Other inclined line, it is wet bulb temperature. And if I want to represent it in the curve with bulb temperature, I will present this only with bulb temperature. And enthalpy not presented direct, but it's presented by another thing. This is what we'll see now.
Sir, where is the wet bulb temperature here in this type?
In this curve, not here. Just a minute, 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 just a minute. Now you see another curve, another chart.
Complicated chart.
This huge, yes?
Yes.
This is the reason to start by the simple one. Actually, step by step. Horizontal, the same, moisture content or humidity ratio or specific humidity, all the same. Vertical, this dry bulb temperature. Curved, this relative humidity. The brown one, this one not important, okay, because the angle of the inclination here is high. But blue, blue sky like this, and the black, this two is almost
Same.
typical, not identical, but almost typical. But actually, these two, it represent for two different things. Here now we have in this curve both wet bulb and enthalpy. In this case, we present only on the chart by drawing wet bulb, and the enthalpy represented by another thing. First, start by wet bulb. I need to be sure this wet bulb or not. The same check we will be do. Here, this is the curved line for 100% relative humidity, and I check the
Dry bulb temperature.
I check the wet bulb temperature here for inclined line 5. this 5 here, you see? And I'm going to down to check what is the value for the light bulb. What we found? 5 also. So the inclined line represent to 5 and the vertical line represent to 5. So the inclined line represent to what? With bulb temperature. Where is it? But in this case, how to get enthalpy? There is no psychometric chart from enthalpy because this represents energy. How can I represent the chart without energy? This is the main. Enthalpy we can check by outside thing, outside scale. What is this? This is scale. You see this scale? This is scale. You see this?
Yeah.
This is scale. Start from here and going up like this, and another scale in this side. This one is scale for this line. 1, 2, 3, 4, 5, and this another scale. 1, 2, 3, 4, 5, 6. Okay. We have here one from above, but I don't know if it is clear or not for all. So we have 6 from here, 6 from here. So what we will do now? I need to calculate energy for this point. What we can do? You bring ruler, okay, and put your ruler here, like this. This ruler, okay, and rotate ruler like this and like this, left and right, up to reach the edge from this side, and the edge from this side touch with the same value. Same like if you imagine this black line is a ruler, you're going left and right up to reach to match between this value and this value, 39 and 39. So the enthalpy for this point is 39. This clear or not?
Okay.
Okay. Any question for psychometric chart?
So how will be the question like?
We'll see some question for that. Going to question? Okay. Okay. Back to presentation. Just the definition for relative humidity, which is defined as a ratio of the mole fraction of the vapor in the mixture to the mole fraction of the vapor in a saturated mixture at the same temperature and pressure. What is the process for psychometric chart? The process in the psychometric chart is 4 processes, and the process maybe can mix it between any 2 processes from these 4. First one is sensible cooling. Sensible cooling. This sensible cooling is just left side horizontal. And we have another option, sensible heating. This totally right, also horizontal. Another 2, which is dehumidification and humidification. Humidification for this part for adding water, and the other one for subtracting water. Both is vertical, up and down, and both refer to latent heat. Sometimes the process is in between, part from the heating and part from dehumidification. So it's the heating dehumidification process. Maybe coming from cooling and dehumidification. So the process is cooling and dehumidification process. It means this is mixed between 2. Mixed between 2. Okay. Other note for this chart, for this process here, if you start cooling, continue cooling, what happens if I continue cooling more? Like this? Correct or not? If I
Yes.
continue cooling, are you going like this?
Yeah. Yes.
No.
No, it will go
If
to
you reach to relative humidity 100%,
it
it
will
means
follow.
saturation line. So if you continue more cooling, you're going along the saturation line itself. And what happened? Condensation. What happened? Condensation during the cooling process. This is the reason of condensation during the cooling process. And this point, actually, in this time, which is at this point, the wet bulb temperature is the same dry bulb temperature. This called dew point temperature. Dew point temperature. All clear now? All these notes clear?
Clear.
Okay. What is this one? This
Wet.
one is a device to measure wet bulb and the dry bulb temperature. Dry bulb, as you see here, is just this fan extract fan. Flow is coming like this, passing through the dry. She is not connected to the anything of the wet like this water. So this one only to measure the wet, and this without connected anything for the water. This dry. This is the device to measure wet bulb and dry bulb temperature. HVAC. HVAC, what is the main objects for HVAC? Actually, HVAC is prepared to control temperature, control humidity, air quality, homogeneous air distribution, noise control, or under force HVAC umbrella. Without HVAC, actually, I think you can to stay at home and sit with me to session today. All I think it is have HVAC, yes? Especially for the area of Middle East for high temperature area. So HVAC is very important topic. First, I will describe with you by easy way the systems and for HVAC. What is the type for HVAC? Actually, HVAC is classified in two main types: DX system and chilled water. DX system and chilled water system. What is the main different idea between these two? As you see, DX is abbreviation for the direct expansion. So from the name direct expansion, it means the air is contact direct with the refrigerant. You remember the simple cycle for refrigeration? Compressor, condenser, expansion valve, evaporator. Actually, the evaporator, if we study for the simple thing for split, the evaporator, this is what we see in the indoor unit. So the air is contact direct with the tubes have the refrigerant, correct?
Correct.
If the air need to be cool, contact with the refrigerant direct, this is the X system. Whatever the any shape of the system, because nowadays it is more advanced. We can use any name with different name. Before, no, this types is DX, this types is chilled water. No, we can use this type or this name of the type under the umbrella of chilled water. We can use this type with under umbrella of refrigeration, direct expansion, and so on. Okay.
Yes.
So you easy. If you see air contact with refrigerant, this is the X system, direct expansion. But if you see the air is contact with cold water, not refrigerant, so for sure this cold water have another cycle to contact with refrigerant to be cold. In this way, on this type, this one is a chilled water system. So chilled water system is almost like two cycles. First cycle, contact between air and water. And this water working in a cycle, okay? Same like the simple refrigeration cycle, but it is closed cycle for the water, and this closed cycle is contact with another cycle which is half refrigerant. To contact between or heat exchange between refrigerant and water, and this water is going to contact between water and air during or by evaporator to make heat exchange for this part. This clear between the DX system and HVAC and the chilled water system?
Yes.
Any question?
No questions.
Hello, engineers.
No questions. Because we are working in HVAC.
Raise voice, please.
No questions.
No questions.
Yes.
Where is others? Engineers.
Yes, yes, no question.
Okay. All woke up.
10
Hello.
o'clock. Now 10 o'clock.
It is not a story.
Now it's 10 o'clock, doctor.
Okay,
Actually-
okay. Almost
actually
we close to finish. Yes. This is the regular time actually for the session.
It's
Up,
okay.
up till now, this is regular time. Just I will take maybe 15 minutes.
Yeah, continue, sir.
Okay, woke up, please. Actually, we finished the part for the theoretical part. Now we're going to some questions and finish. Okay.
Yes.
Vapor absorption system using ammonia. Water is required for
C for cat.
absorber,
See,
separator, and condenser.
Yes.
Which of the following statement is correct?
A. A.
Yeah.
Yes, correct.
A is the answer.
Relative humidity is
A ratio of the water vapor actually present
Also
in
A.
compressed element.
yes, correct.
Yes.
Psychometric chart. What does the vertical line parallel to the ordinate indicate?
Dry bulb.
Dry bulb temperature.
D.
Delta. D.
Dry bulb, correct. What can be measured by a line psychrometer?
B.
Sling.
Sling.
Actually, we
Specific
can
is-
measure dry bulb and wet bulb both.
Okay.
What does the curved line on the psychometric chart indicate?
Relative
D.
humidity.
Relative humidity.
Relative humidity.
Yes.
Which of the following degrees during sensible cooling of air?
Dry bulb temperature.
During sensible cooling of air.
Yeah, dry bulb temperature.
Dry bulb temperature.
Yes. Specific level temperature.
Dew point temperature is constant as long as there is no change in
Moisture content of air.
Moisture content of air.
Yeah. Relative and specific. No change. Moisture content.
sensible heat factor is given by
D for Delhi.
sensible heat factor.
No idea. What is it?
Delta. D.
sensible heat factor is given by sensible heat divided by total heat. Okay. What is the effect of superheating in a refrigeration cycle?
C. Increase COP.
Decrease COP. Because superheating, if you're going to be more superheating, the curve is going like this. You remember the chart, something like this. So if you're going to superheating, this is the normal one. The shape of the line, if you're going right like this for the compressor, start from here, for example, the line is going like this. It's not parallel. So this value increase. So work compressor increase. So COP work compressor in the denominator. Correct? So this one increase, COP decrease. Clear?
Yes, sir.
Okay. When does the refrigerant exist at a saturated liquid in a vapor pressure compression cycle?
After evaporator. Saturated liquid in a vapor.
C.
After passing through the condenser.
After passing through a condenser and before passing through a condenser. Give me final, please.
After passing through the condenser.
Yes, correct. After condenser, it will be saturated liquid, sure. Highest temperature of refrigerant in a mechanical refrigeration system, what occurs?
D.
Yeah. In evaporator.
Which one?
In evaporator.
Delta D.
Between compressor and the condenser.
Oh, okay.
How is the capacity of a refrigerating machine expressed?
C for cat.
Yeah.
Yes, C.
Yes, makes sense. Absorption system normally uses the following refrigerant.
Ammonia.
Ammonia.
Yes. Relative COP is equal to
A.
Theoretical COP. Yeah.
yes.
Yeah.
For us domestic refrigerators, the COP is
More than one.
Yes.
almost all more than one. What is the most distinguishing feature of absorption type refrigerator?
Quieter in operation.
D.
D
Quieter
only. Yeah.
operation.
Quieter in
Quieter
operation.
operation.
Quieter operation. What's the answer?
C for cat.
24 hours. In 24 hours.
Correct. One time refrigeration corresponding to?
Yeah, 50 kilocalorie per minute.
Yes.
Yes.
Yes, correct.
In SI unit?
210 kilojoule
210 kilojoule per minute.
per minute.
210, yes, correct. Moisture in refrigerant is removed by, think
Dehumidifier.
carefully and give me answer.
Dehumidifier.
Dryer.
Humidifier.
Safety.
All agree?
Yeah.
Think so.
All agree?
Yes, sir.
Yes, sir.
Actually, moisture in refrigerant, not in air. Dryer.
Yes, nice.
Refrigerant for the refrigerator should have
High latent heat.
sure.
Yes,
Yes.
highlight and
Which part stops spark and the fire inside duct?
Fire damper.
Yes. Device installed between the air handler and duct supply return is called
Splitter damper.
letter
Splitter damper.
control damper.
Splitter also.
Splitter not in the at the beginning. This is splitter between if you need to make separation for the duct itself. Device to be installed in between fire rated wall is
Fire damper.
fire damper. Which membrane can be fixed vertically or horizontally between fire rated wall, which controls the spread of the smoke?
This is E for England.
This is yes, fire or smoke dampers. Correct. Prevent the spread of smoke inside the duct and the fire resistance rating from room to room.
Fire damper.
Fire damper.
Yes.
That's it. Finish. Actually, only one session remaining. Sunday, inshallah. Next coming Sunday. This session will we cover the part of the stress analysis. It's not a huge part, the simple part, but it's important, very important, and the equation inside this part is very important. And also we will cover the exam 7 because almost many questions related for the part of stress analysis. If anyone checks the exam 7, you will find that. Okay.
Okay, sir. Right.
Okay. See you inshallah
And,
Sunday on the
okay,
same
sir.
time at 7
Doctor.
o'clock. Okay.
Thank you,
Sir,
sir.
one question.
Yes.
Regarding this, how many questions will come in the refrigeration
How many questions? What?
in the exams? How many questions?
Final exam?
Yes.
25
The-
questions.
No.
Refrigeration system.
Refrigeration.
It depends. Not in the exam,
Depends.
nothing can be expected.
Okay.
Maybe exam have many questions for each Hvac, 4 or 5 questions in the exam. Maybe you will found one maximum.
Okay.
Okay.
Okay. Thank you.
Exam for mechanical, especially for mechanical, it's not. It can be catch for the exam. Focus for this or this. No. Difficult. Just try to cover everything and go into the exam, and inshallah will be well. But study hard first. Okay.
Sir, I have one question, one doubt for exam 6, question number 10.
Question number 10.
Yes. Actually, what should be the X in this case? I am confused.
Question number 10.
Yes, exam 6, question number 10.
Exam 10, question number 6. Okay. What's the problem? SI units of bending moment?
No. This is the space between two plates, 20 centimeter or 20 centimeter.
What's the problem? We solved this one in the first session. Fluid mechanics.
But actually, sir, it's asking what will be the velocity in meter per second of flow at a point 0.5 centimeter below the lower surface of the upper plate. So my question is that
Yeah. I
1
understand
centimeter
it.
or 0.5 centimeter?
Yeah. For 0.5, the answer is not here. For
Yes.
0.5, the answer should be 6.25.
Yes, 6.25. Okay,
Yes,
okay.
yes,
Yes,
correct.
that is why I'm confused. Okay,
Yes.
so it's okay.
About.
I have one more question.
Yeah.
Actually, if you see, the density of the water is 62.4 pound per cubic feet. Okay, but a specific gravity also showing same in, if I see in the internet 62.4, because a specific gravity is rho g of water.
Again, please.
No, density of the water is 62.4 pound per cubic feet. Okay.
Density
And
of the water.
yes, density of the water in
Yeah.
FPA system. Okay, but if I see in the internet, is also showing a specific gravity of water is also 62.4. So how?
Because this for water specific gravity one. No?
A specific density for the water is not 64, it's 60, something like this.
No, it's also showing 62 because a specific gravity is rho g. So if we have rho is 62.4, then it should be different.
Yeah, but is this I have some doubt for this one
Yes.
between the between the density and you talk about for the density and the specific
Yes, gravity of the water. Because if you